Next up, we are thrilled to welcome Dr. Mark Raybert, founder and executive director of the AI Institute, and author and futurist August Cole, who will discuss how America can push the frontier of robotics.
Well, it's an honor to be here and to be with Dr. Raybert. We're going to be talking today about our intersection with robotics and AI, what that looks like from a technology and trends point of view, but also the human-machine interactions that determine so much how we both integrate those capabilities in society, but also how we respond to them at an emotional level. So Mark, thanks again for joining us. And I'll open up with a question that looks at your arc of your career, over decades at Boston Dynamics, where you helped launch products like Atlas. Also your work now at the AI Institute, working on envisioning a future with technology that's very aspirational. When you take that historical experience you've had and project it forward 50 years, what do you see out there for robotics?
Well, I'll paraphrase what the last speaker said. 50 years ago, when I was a graduate student at MIT, just starting on robotics, I couldn't have imagined where robotics would be today or anything about my path through those 50 years. And so I feel that way. 50 years is like infinity in this space. There's so much going on. There's so much exciting stuff. All of you who have been following the AI activities that are going on. And that's just like 18 months, right? It's been like a tidal wave. It is true that if you look over the 50 years I've been involved, AI has been like this. It's gone up, it's gone down. People were optimistic, unreasonably optimistic, then unreasonably pessimistic. And I assume some of that's got to be true today, too. I know there's some people who think that AI is going to solve all problems in robotics. In fact, maybe it already has. I heard someone stand up at a meeting and say, now that vision is solved, we can, I don't remember the rest of what they said. Yes, your phone can find some of the pictures on your phone that have a cat in it, but that's a lot different than using real-time vision in a robot in order to chase the cat or pet the cat or whatever you want to do. So there's a ton to do. I think the current revolution in AI is going to help a lot, but there's also a lot of gaps that we're going to have to work on.
To reach the vision in many ways of what you're working on at the AI Institute, technologies that can help us literally live better as humans, what are the areas of investment and really, I guess I would say, opportunity that you're trying to draw people's attention to and highlight right now?
I think one of the key things that we're trying to do is combine, if you look at robotics, they've come a long way in their physical capabilities. I'm sure many of you have seen our Boston Dynamics' dog robots or the so-called humanoid robot, Atlas, handling parts or running around or jumping, doing backflips and things like that. Physically, they still have a lot to do, but you can see a path, and I think if we work diligently, we're going to make them better and better and better. But their cognitive function is really nowhere yet. I like to say there is dumb as, and then pick your favorite thing, a doorknob, a toaster. The difference between interacting with another person and interacting with a robot is just day and night. So I think making them smarter is the thing that's on the immediate agenda to try and work on that. I don't know how long it'll take to really make them have semantic understanding. But again, referring back to the previous speaker, at the end there, he was talking about taking on impossible jobs. And one of the things I've been pitching to our people is to be technically fearless. And in my book, technically fearless means being willing to take on a problem that you don't know how you're going to solve. And I think there's lots of good problems out there where you say, boy, if this could be solved, it would be really useful. I don't have a clue. Frequently, engineers and scientists take on problems where they do have an idea, and that's one kind of thing. But taking on one where there's just a mission, and you hope you're going to be able to chip away at it or whatever, or find a breakthrough, that's another kind of challenge, and one that I find really inspiring. And I think young people, setting out find that inspiring too.
I'd like to pull that thread. Throughout these sessions, we've been sort of passing a crown from moderator to moderator so that someone can be king for a day. So if it's your turn, which of those would you select as problems to tackle that you just kind of mentioned being urgent, impactful, relevant to people at a human level?
Well, semantic understanding. So I don't believe that the current LLMs really understand the things that they're talking about and giving you information on. I think they're more like collators of information, with vast reach, very useful. I'm not saying anything about there not being utility. But, getting the underlying idea of what the utility of something is and being able to generalize that from one thing to another. I'm looking at the table over there. The yellow potato chips and the black bag of potato chips, I know they're both bags with food in them, and you could have almost any bag of anything with food in it, and I would understand that and be able to operate accordingly. And there's so many ways that human beings are smart about the world that machines and robots don't yet have. I think that's the most important problem.
And what does that do for the relationship that we have with the devices that are around us? I mean, all of us are basically bonded with our phones in our pockets. You see how people react to videos online of Atlas. Sometimes people, shout with joy. Other times people want to lock their doors and pretend the future's not coming. That rise in robot intelligence or capability is a better way to say it with AI. Is there a need to kind of manage that at a research level, at a society level? Are we keeping pace?
I think there's two separate tracks. At least in my mind, there's two separate tracks. I look at the media and see the reporting on our robots. When I say our, I'm referring to Boston Dynamics. I'm only on the board of Boston Dynamics now. I'm really working at this new institute, but I still call them our robots. If you look at how the media talks about our robots, frequently the word terrifying is in the title. And in fact, there was one news story from the Washington Examiner that the headline on the front page said, "North Korea is no longer the biggest threat to the United States. It's the robotics company Boston Dynamics." And it had a picture of me with one of our little quadruped robots. Now, I know that's not typical of the media, but if you go out and look, there is a great desire to report on how people are afraid of robots. But my personal experience going around the world showing robots, I take them to shows like this, is that people are it's like a magnet. They really want to see what it's doing. If we give them a chance to drive it, they love to do that. And if you look at our YouTube thumbs up and thumbs down, we get massively positive responses to most of the videos, even though some of the comments are about Skynet and them taking over. So I think there's an interesting tableau of responses out there.
I mean, your mention of Skynet, and for those of you that haven't seen the 1984 James Cameron film Terminator, and the sequence of films that followed, but that introduced this idea of sort of cybernetics, right, in a kind of precursor era. Narrative is something dear to my heart, and I think about it a lot with technology. Do you see narratives in robotics shaping adoption at a civilian level, but this again being a national security focused group, how robotics is going to be adopted by, the Pentagon is a very complex organism, but let's just say the US military writ large?
I do. I went to an international meeting that I believe was in Seoul, where they had representatives from lots of different countries, the United States, Great Britain, Korea, South Korea, I don't remember what else. And it was about regulation, government regulation of AI. It was mostly focused on AI, but AI and robotics. And I would say that fear of the risks dominated taking advantage of the opportunities. So I'm always talking about trying to get those in balance. I think all technology has risks, but it also offers great opportunities. Like basically everybody speaking today has been talking about the opportunities of technology to helping us be safer and to deal with our adversaries and things like that. So getting that balance right and not letting regulation stifle things. I mean, that's right in my front view of that.
You know, the conversation around ethics is part of that too, and I know the AI Institute, you're beginning to work in that realm, you know, for the Defense Department, which has been very out front on its AI ethics and devoted a lot of time and money and you know, just human, you know, cognitive power to figuring out standards, if you will, or at least something that represents the way that the U.S. would like to operate in the world. What is the kind of frontier we're at with robotic ethics? You know, both in terms of, you know, whether build, not build, or whether it is, again, creating a sense of ease or comfort among the general public? Is that ethics have a role to play? Because I often wonder, you know, trying to understand the role of ethics in these kinds of really, you know, technology, research-driven fields, it can seem like the science and investment just outpaces, you know, the should or should not.
So let me again say there, give two kinds of answers. I think if you, you know, in my interaction with the world, I get three kinds of fears. One is that they're going to take people's jobs. One is about weaponization of robots and what that means. You know, some people are afraid of, I guess, of all militaries. There's military, but there's also police use of robots. And then the third one is AI and robotics going to just somehow go berserk and take over everything? I don't worry too much about the berserk part. I think that's mostly a fantasy, fueled by Terminator and those kinds of things. I think the jobs part, the interesting twist lately is all the discussion about declining populations. You know, North America, Asia, Europe, there's lots of countries who have below break-even birth rates. And I think there's going to be a time when robots and other kinds of automation are a savior in terms of achieving productivity without workers being available. I know the other discussion is whether robots are going to take jobs, and you know, someone was talking about reskilling this morning. I think that's important too. But I think there's a good chance, and you know, we work with people who run warehouses and things like that, and they all complain bitterly on what the turnover rate in their employees are, and how hard it is to find people to take those jobs. Apparently, young people have a different attitude towards those kinds of jobs than the other generation. So, you know, there's a lot of flavors of discussion that we could have about these things. At my institute's ethics group is trying to get real data about some of these problems, not talk just broadly about the issues and pontificate, but to kind of collect data by doing surveys, trying to survey people who aren't necessarily techies or students at tech institutions, which is where a lot of the data currently comes from, but going out to other kinds of populations. And I think there's an opportunity to get some information that would help guide some of the government and other people coming up with regulation.
And that sort of product would look like, what do you think, guidelines or milestones?
I think we would, right now we're trying to go one stop short of guidelines and just say, here, we did this study, here's what we found. People really are more inclined to have these kinds of attitudes than those. Or here's the things that there's fear about, and they're not worried about that. Because I don't think we even have that data. Even about jobs, what the possibilities, you know, what things can robots actually do that are going to affect people's jobs? How do people feel about their jobs right now? So we're trying to go with those kinds of things.
So, you know, in addition to ethics, what other areas are you researching and working on at the AI Institute that you think will help kind of advance society, you know, towards this future where there's a lot closer integration with technology?
I think on the productivity side, one of the big limitations of robots is how hard they are to program to do particular tasks. And I would wager that anybody in this room could go to a factory and get anywhere between 15 minutes of on-the-job training and let's say 2 hours, and be able to perform a task that had economic value. It takes a whole room full of very skilled programmers, weeks or months, to get a robot to do anything like that. So we have a project called Watch, Understand, Do, where our goal, and again, we don't know how we're going to accomplish this, so it's science fiction today, is to have a robot watch a worker do a job, determine what the sequence of subtasks are that they're using, determine the skills that they're applying, and then be able to maybe ask some questions or get some guidance, but maybe not, and then be able to do the job themselves. A next step would be a project we're calling Inspect, Diagnose, Fix. Boston Dynamics actually has robots in facilities where they're going around and collecting data on the machinery in the facility, things like a pump or a compressor, and they're listening and looking and taking temperature of those things to figure out how well they're working. But right now that data just goes to people analyze it. I think pretty soon AI will analyze it. But they can't then go and say what was wrong with it and then go and fix it. But I think, I hope there's a day while I'm still alive when we can inspect, diagnose, fix with machines doing those tasks. Those are two examples. You know, we're working on about a dozen different projects.
Is that sort of zero-shot learning something that we'll see more broadly used, do you think, where you can literally set a robot loose in a room and say, you know, watch, you know, and learn?
I think doing learning that doesn't require the massive amounts of new data that the LLMs and most foundation models require is a goal, not just for roboticists, but everybody working in AI. But I don't know, you know, how close we are to that. I know there's some areas where we can get pretty close by doing a lot of training and simulation, and then just a little bit of real-world experience takes it over the edge to make the physical. That's called the sim-to-real gap. But it's you know, it's a hot topic in the field these days.
You know, the design in robotics seems really crucial in how humans relate to them. So in this kind of, you know, concept of human-machine interaction, are we going to see more things like soft robotics, like non-standard, you know, non-bipedal systems that can, you know, share more of our physical space with us, whether it's our households or our employment? Because it feels like the more we try to make robots like ourselves, the worse emotional reactions we have to them.
Well, I think I heard two questions in your question. One is, are we going to find ways to make robots more comfortable with people? And I think making it so that the human can understand what the intentions of the robot is a really important thing that people are starting to address. Things, very simple things, like having the robots having lights on them that are a cue as to what's going to happen next. You know, even forklifts now in factories sometimes project a light in the direction they're going so that the other warehouse workers can tell whether they're going to get run over by this thing, you know, where it's traveling. Our ethics and policy group is doing an experiment where they have someone who's a horse expert, and it turns out that there's some part of training people how to interact with horses where they get used to each other, and they get used to both trusting each other and being able to know what to expect in the behavior of the others. So they're looking at whether or not you could use those kind of techniques for a robot, and I think that's kind of a clever thing to go after. I'm trying to remember what the other part of your question was now.
The idea of just being in more physical proximity to robots, what it will take to get us to that place where we're going to be potentially living alongside.
Yeah. I think a lot of people are focused on when we're going to have robots in our homes. And I think that's not the first place they'll be. I think they're going to be in warehouses and factories, places that can be organized, where there can be lots of rules of interaction, so that the robot doesn't have to be perfectly safe in close proximity to a person, because the people will all be trained to stay out of the way. For instance, that's what's kind of going on today. Gradually, the robots will become more perceptive of people and what's going on around them, and then they can interact more. But it's going to be a while before you can do that in a home, where both things all operate at closer quarters, where the people may not be trained. There'll be children, presumably, in lots of homes. The houses are more disorganized. I'm not casting aspersions on your house, but certainly my house is more disorganized than most factories and things like that. Yep. So that's not going to be the first place we see robots. And also, the cost of the robots will take a while to be at a place where they're affordable in our homes. So I think we're going to see them other places. But I do have friends who are working on robots that could be companions. You know, there's a lot of people who need companionship that they're not getting. Sort of try and take the role of pets. And I'm kind of optimistic to see what they can do.
I mean, there's a trick in writing called Pet the Dog where, you know, you can have even kind of a terrible person be kind to an animal. John Wick is a great example. And immediately an audience is going to connect with them differently. So could you actually expand on the robot pet concept? Because I actually think it is an interesting pathway or gateway, maybe is a better word, towards that living alongside with robotics.
Well, I'm not an expert at this end of things. I will say that the basic concept they're working on is to do something that, you asked about soft robots too, that is soft and cuddly like a pet, but it is just a robot instead. You don't have to feed it, except you have to charge it, I guess. It doesn't poop, so you don't have to deal with that part of things. But it's something that you can attach yourself to. You know, people get attached to all kinds of inanimate things. It can have a little animation that helps foster that. It could be a communication device. I have to say the field is littered by failures in this space so far. You know, about 3 years ago, I think there were 3 companies that were trying to do home robots that all went under. But that's not a reason not to give it another try and you know, come at it with a different angle.
I mean, you raise an interesting point about market time. Timing. You know, this notion that the kind of buying public, if you will, let alone government, has to be ready. I mean, this is clearly a problem like defense. You know, DIU is working on for DoD, similarly on the kind of civilian marketplace, commercial marketplace. What are the things that are going to change, do you think, in either product or also perception that kind of begin to narrow that gap? And it's a little bit of a extension to the thing we were just talking about.
I do think it's an extension to how easy it is to use. If I can go to like a technical area, I have friends who have robot companies that do pick objects. They're calling each picking. So, you know, when you buy an object online, it has to get picked out of a place where there's a bunch of them and put in the box that's going to go to you. And you know, that's a hard problem, but people have worked on each picking and have solutions. But to get that each picker integrated with the rest of the facilities that is at that provider, whether it's a warehouse or a retailer, the costs and the challenges of doing that, because the robots are stupid and they have to have lots of IT interaction, that almost kills the value of the robot. I have other friends who are integrating the whole solution, where they're doing the whole warehouse and automating the whole thing so that they don't have multiple parties interacting. So I think that you asked sort of when's the right time, and I think dealing with these things that aren't exactly what the robot does, but how it interacts as a system, and what all the pieces of that system are a really important part of the question. And all those things are evolving and coming along. I didn't say at the outset, it's a fantastic time to be a roboticist. I mean, there's so much going on. I love robots. I have for 50 years, and it's really just a pleasure to work on these things.
Unpack that,
despite the challenges.
Because we've got students in the room. We have people who are various stages in their careers looking at this, and having worked in the AI space for a bit as a non-technical person, been surprised by how much need there is for people who, let's say, have liberal arts backgrounds. In the robotics field, where are those areas of opportunities? If you were, say, an undergraduate right now or a graduate student, you would be maybe, directing your energies.
I mean, it's just totally open. You name it. Working on the perception of let's see, at the technical levels, working on the perception of the robots. A thing people forget is that the hardware, the mechanical hardware, is still a huge challenge. A lot of people think it's all in the AI, and if you can make the computers smart enough, they're going to make up for whatever the limitations are of the hardware. I'm not one of those people. I think that the smarts and the computing and the hardware and the sensors all need to fit together like this. And so you just look at the range of disciplines in any technical school, and we need all those. No shortage. And there's the ethics side. Very few people working on ethics and policy and those kinds of things. Then there's all the business people and entrepreneurs. I know a lot less about that.
Yeah.
Despite having run Boston Dynamics for a long time. We're really all techies motivated by making the technology take the next step.
When you go back to your robotics journey and the origins, what was it first that made you pick this path versus, of course, many of the others you could have?
Oh man, it's a hard question. I can tell you, I became a roboticist on one day. Well, first of all, when I was a kid.
In one moment, you mean?
Yeah, and I'll get to that in a second.
Yeah.
I mean, the whole time I was a kid, I was in the basement breaking my father's tools and building contraptions. But when I was a graduate student at MIT, I was actually in the Brain and Cognitive Sciences department doing neurophysiology. And I didn't like doing neurophysiology very much. And I followed one of the professors back to the lab, and there was this robot arm in about 1,000 pieces on the table. And from that day on, I was a roboticist. Something about that just got my juices going, and I worked in that lab and never turned back.
That true sense of discovery is pretty magical when you can tap into it.
Yeah, tied to the hardware, but also the challenge of making the hardware do something interesting.
Did you find you had to learn the software along with it, or was that more of a collaborative team approach?
You had to do software. I did software, but I also went to the machine shop and made stuff. And if you look at my organization, both Boston Dynamics and the AI Institute, every kind of skill is important. And it's not just the PhDs. We have a lot of PhDs, but the technicians, the designers, all those pieces fit together. And we try and get the culture where all those things are equally respected and leaned on. I'm always telling my people that teamwork is one of the things. There's a lot of discussion this morning about universities and their role. I was an undergraduate at Northeastern, so having the president here was kind of fun. Although it was a previous version of Northeastern when I was there. And then I was a graduate student at MIT, so we had the MIT guys here. But one of the things that the universities don't cultivate enough, in my opinion, is teamwork. If you want to do this kind of work, your skill, whatever it is, really needs the help of all the other skills. And you're only really smart if you're working with those other smart people. Right now, everybody at my company is smarter about what they do than what I do, than I am about their thing. So I think encouraging people to get experience working on a team is really important. And the other thing I always encourage is getting hands-on experience, whatever it is you love doing.
Your prior point about ecosystems, it's easy to watch YouTube video of Atlas or to look at a quadcopter in Ukraine and think that's the objective, that thing. But you're really talking about a systematized approach to making robotics useful, scalable. We've heard throughout the day the challenges that the Defense Department has in both scaling but also figuring out how to buy systems like that. With your experience in robotics and looking at both corporate adoption and others, are there some lessons learned that the people in the room who are wrestling with this, because for all the good intentions, it's still a very, very uphill hike, I think, that people who work on that stuff would say today?
I think I have to start by making a confession. I don't think robotics is a success yet. Compared to computers and lasers and airplanes and cars and, you can name all these things where they're making tons of money, there's tons of the product, you use whatever criteria you want, they're, incredibly useful. The cell phone, I left it in the back in the green room, but, my cell phone, those are amazing successes. Robots aren't like that yet. I'm a robot lover and I'm committed, and whether they're a success or not, this is what I'm doing. And again, back to the question of young people, I think if young people can find the thing that they're in love with, that's what they should do, independent of how successful it might be immediately or later. I don't know what it takes to have that kind of commitment. But your question was sort of about the system. I'm not a system guy. I do know that designing good robots involves doing system engineering, where it's not usually about any one component, but how the pieces all fit together gives you much more leverage than worrying about having this magic bullet of a widget that does this one thing. And if you look at Boston Dynamics, a lot of its success in making their robots is because they've really invested a lot in the system engineering and understanding required to do that. And I think that's probably true pretty much across the board in these kinds of technologies.
You know, with and a corporate customer is obviously not the same as a government one, but you know, are there traits or facets of the way successful roboticization of whether it's dark warehouses or other production of manufacturing, are there traits that you could identify that might be relevant in this kind of national security context, do you think?
I want to go back to what the VP of research at MIT said. He talked about the hockey stick and the handle being as important as the thing. You know, what I feel like has happened with my work is that, you know, I had a lot of government funding from DARPA, ONR, you know, the other DoD groups. And they kept this ember alive for about 30 years, and it had no economic value during most of that time. And now you can start to see, oh, this stuff could be used here and here and here, and people are starting to commercialize it. But he was right that investing in that long part of the hockey stick is a key part of the thing. And I'm really, you know, even at the institute I'm in now, we're not trying to make any revenue or making products. We're trying to work 5 or 10 years out. And the fact that we have investment from Hyundai, a South Korean car company, and they're betting that without showing them saying, here's a problem we're going to solve for you, but saying broadly, this kind of technology will be useful. That's a bet on the long part of the hockey stick that I'm surprised and impressed that they're willing to do.
Do you have a sense of how far we are from that? I don't know if inflection point's the right word, but let's say the curve, you know, steepening.
The more organized the application, the more effective it is. So warehouses, there's lots of robots starting to be used in warehouses. Police forces are starting to use our Boston Dynamics robots to act as kind of a mediator between all the armed parties so that they're not immediately shooting at each other, which has been very effective and starting to get traction. I think, as I said before, I think the home is going to take a while to have success with.
I mean, it does feel like the different armed services, the Defense Department would be suited because of its structure, its doctrine, its rules and regulations, and yet, as Eric Schmidt mentioned, as others have mentioned, there's a cultural challenge, I think, right, in different parts of these entities and institutions. Convincing people outside of true national exigency, what is it going to take for a program manager in the Air Force to put that funding line on the line literally and say, I want to acquire an attritable system that threatens my relationship with someone who's committed to a more traditional way of doing something like that? These feel like very human problems, and we're talking about machines,
Yeah, I don't know. You're asking the wrong guy. I think I'm kind of the robot builder. I think the people here are probably better suited to do it. I'll say one thing. When we were making a big-legged robot that was called LS3, and we had it out for some military exercises, really as a showpiece more than it was actually being used. And on the one hand, a lot of our sponsors were very excited by it, continued to be supportive. And then one guy said, oh, this thing's too noisy. And so the media picked up on the too noisy and then decided that the program was killed because it was too noisy, which wasn't true. We still had funding and we continued to work on it because the supporters could see all the good things it could be used for, carrying the load for dismounted infantry and things like that. So I'm pointing at the fact that the military, or the people you're talking about, there's a lot of different people with different opinions. It's not one thing. And somehow, herding the cats, I guess, is part of the job.
That's literally a job in the Pentagon, in various offices, yes,
yeah.
Cat herder. The idea then that there is this future over the horizon, in our society in the US, but in other societies overseas. When you travel internationally, what are you seeing out there that kind of portends, we're reaching actually that asymptotic point, of, again, adoption, of the hockey stick steepening, whatever the metaphor?
I think we're doing great here in the United States. I think that there's, especially in the last few years, there's been a lot of investment in robotics and a lot of progress. I'm excited to be a part of that. I went to China for the first time about a month ago and visited several of the companies building humanoid robots. And on the one hand, there were dozens, maybe many more than dozens of separate companies all building humanoid robots. And most of them were pretty limited in their capability. There's only one really who I think steps up above the others. And the others were very limited in their capability. On the other hand, assuming that there's somewhere between 20 and 50 and 100 people at each of these companies, that's thousands of people being trained in the skills of designing, building, testing robots. And I think that is a statement about the future of what's going on there. I'm not sure that level of cultivation is happening here, or at least more of it is focused on shorter term productivity, shorter term revenue. And I worry that there's not enough work looking further out on the horizon and cultivating that.
In a comparative sense with the Chinese companies, is that a kind of different funding models or business models, do you think, or?
It was very hard to determine what the real funding model is. If we asked several of the companies how they're funded, and they would say it was all private funding, but it was clear that that wasn't really true, and that the government was involved. We went to one place that was a startup that was less than a year old, and they had a building with 19 floors in it. Most of it was empty, but they'd committed to taking on this building. Now, how do you do that? I think that they were part of this industrial park where there was some lubrication for how you get access to that space. That was just one data point, but I think it's probably indicative of what's going on.
And were the kind of market use cases more industrial or kind of
retail? Most of the ones I saw were retail focused. They had demos of things like going into they had something that looked like the mock-up of a drugstore, and it was picking products off the shelf and putting them in a bin. But it was a real mock-up, not very, to be honest, not very convincing.
When you
as a hardcore technology guy.
Are there other countries or societies you've seen, make mistakes with robotics that they've corrected and kind of moved on that offer any cautionary tales, perhaps?
I wouldn't describe it in terms of the nationalities, but I think that there's a checkerboard of interesting companies. I won't go down the list, but some of them are being very creative and aggressive. Some of them, not so much, but there's a lot going on.
One of my favorite things is when AI designs robotics and you get things that don't look like that any of us could have, in our most creative moments come up with, at least naturally, without assistance. And do you see that as any kind of a path forward, where we're going to get presented with options that are going to be very effective at what they are designed to do, and it's going to be uncomfortable for us to see?
Well, leaving off the uncomfortable, I definitely think that there's opportunities in doing things that are really thinking outside the box. And, even, at Boston Dynamics, we started having a humanoid robot handling boxes, like what happened in the warehouse. And then we started to focus in on, well, what would make this be a simpler machine that would work better? And then they came up with this thing called Stretch, which doesn't look like any animal. It's got one arm, it's got a base, and it's designed to work inside of a truck so you can unload boxes. So it was interesting that the evolution didn't go from a machine-looking thing into a humanoid. It went the opposite direction. The other comment I would have is today there's so much focus on humanoid robots. Boston Dynamics has theirs, Tesla has theirs. There's about 5 other US companies that are the prominent ones on robots that are so-called humanoid. Not only aren't these things very much like humans, in most cases, I'm not sure they're the quickest path to making money, to having productivity in particular applications. And so I think we'll see, we need to see a diversity of what these machines are, whether they're designed by people or by AI.
One of my favorite Hollywood Robots is not the Terminator, although I love that movie. But in Interstellar, a Christopher Nolan film, there's a robot that basically, I think it's called TARS, which is a slab monolithic-like thing that can both, tripod around, but also can almost cartwheel, which I think is really eye-opening for that possibility. The engineering that it takes to get people off the humanoid robot, X, is that something, do you think we're already there, or are we going to continue to kind of be held back a bit because we were trying to develop something that isn't our image?
I don't think we're held back. There's plenty of people working on purpose-built designs, and I think they're making progress. I will say, I resisted Boston Dynamics having a humanoid robot for many years. And then we had a customer who wanted to test, it was the Army actually, who wanted to test personal protective equipment, and they wanted to use actual suits. So the robot had to be the shape of a person, it had to have other characteristics, had to do the motions of a person. And that was the trick that got us to start doing it, and then it got a life of its own. I will say that if you look at public reaction to the robots, for instance, I count YouTube hits because YouTube had a lot to do with the success of Boston Dynamics. You get 10x the reaction to humanoid robots as you do to anything else. Does that matter? It's probably true even among DoD funders. At least it has some effect, even though I think it's too much of a reaction, and that we should be focused more on what the functionality is, mobility, dexterity, perception, and intelligence. Those are the things that matter.
That's a fascinating data point. A last question, if you'll permit me, if you're willing to share, what kind of robots you keep in your own house?
I had a Spot four-legged robot at home for a while, but I didn't use it enough, and I thought it would be better hands for people at work. I did have I'm spacing on the name, although someone mentioned it at lunchtime. I had a little toy robot on the counter for years that you could talk to, and it would look at you. And Anki, exactly. I think it was Vector was the one I had, but I don't have anything at the moment.
Well, thanks again for the time, Mark.
Okay.
Let's give him a round of applause, please.
Thank you.